Find time of beam. Find time of beam. Okay? They're related, but they're slightly different. So you are steering 0, 3, 1 true. Okay? You're steering 0, 3, 1 true. So I'm just going to do this 0, 3, 1. Okay? And a light is picked up dead ahead. Olivia, you're steering 0, 3, 1, and a light is dead ahead. What's the bearing to the light? 0, 3, 1. Okay? This light is on my course heading. So I'm just going to arbitrarily, if I want to have a picture, I'm going to arbitrarily put a light. Okay? It's fixed, not floating, because if it was floating, it would be a triangle. It would be a diamond, right? Anyway, so how far is that light ahead of me? Okay, so I'm here. It's 12.7 miles. What time is it? Don't look at your freaking watch. Read the freaking problem. Oh, it's 0017. The last problem, see, look at the last question, look at the last sentence of the problem. What is your ETA of beam? They want you to give it in time. So somebody has to give me time. In order for me to give it time, somebody has to give me some time. They want clock time here. Okay? So now, you are steering 031, and a light is picked up dead ahead at 12.7 miles. So I just put a little light arbitrarily on there, 12.7. Give yourself a little room to work. You change course to pass the light 3.5 miles on the starboard beam. Okay? So you don't have to draw this circle, but I'm going to draw this circle. What's the radius of that circle, Nolan?
3.5 miles.
3.5 miles. Okay, Nolan. Now, it turns out, are they asking you for a course here?
No.
No, they're not. So it doesn't really matter if you draw it this way or this way, actually. Okay? I mean, it kind of does because, you know, one way is right, one way is wrong. But for the answer, it doesn't matter which way you draw it. But I'm going to draw it the right way. So the right way is you change course to pass the light 3.5 miles on the starboard beam. Oh, God, the top. All right. So I'm going like this. If I do that, it's going to be my port beam. If I do this, it's going to be my starboard beam. I don't really have to do this, but I should do this. And I'm going to draw it tangent to that circle. Now, do you need the circle? No, but I'm just trying to help you kind of relate. Oh, CPA, da. And by the way, this is how you're going to do it on the maneuvering board if you decide to do it on the maneuvering board. So some of you might say, that's the trick. I just want to do it on a maneuvering board. I'm setting you up to do it on a maneuvering board right now. Okay? All right? Because you will draw a circle like that. Okay. Now, Katie, you change course to pass the light 3.5 miles on your starboard beam. I got to draw another leg up there. I got this leg, which is 12.7. I'm going to do some new leg over here, but there's one more leg. How am I going to draw that leg in there, Katie? What is it? How long is that leg, the missing leg? It's related to this circle. It's related to this circle. It's 3.5 miles. So am I going to draw it like this? Am I going to draw it like this? Am I going to draw it like that? Am I going to draw it like that? Am I going to draw it like that? Am I going to draw it like this? Okay, so I went up to the new line. 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 4 of those are wrong. Only 1 of those is right. Which one of those lines is right? 1, 2, 3, 4, 5. Which one of those is the right line? Read the last sentence again. What is the ETA? What? A beam. Oh, okay. So if I'm steering this, and I'm looking out the window, you tell me when I'm looking at that thing of beam. So here we go. You ready? I'm looking out the window. What kind of angle is that?
90.
That's the right leg. The right angle goes between whatever you're steering and the bearing. That was a crucial step in this process. Why? Okay, I'm going to just redraw this now. Okay. 0, 0, 1, 7. Okay, there was some buoy. I want this to be 4, and this is 12.7. Okay? And now I want to know, this is going to be a right angle. And now I want to know what time. Hey, don't confuse the story with the facts, okay? Okay? How am I going to solve this? I can go back to using trig if I want. Okay? But what I need to do now is I need to solve the length of this leg. Solve the hypotenuse. Okay? Then solve ETA. So how am I going to solve this hypotenuse? A, B, C. I'm going to use the Pythagorean Theorem. Actually, no, that's wrong. It's a good thing. This is A, B, C. The hypotenuse is the C. Okay, so if you get your right angle in the wrong spot, you're screwed. So A squared plus B squared equals C squared. I'm looking for A squared. Well, I'm looking for A. So A squared equals C squared minus B squared. A equals the square root of C squared minus B squared. A equals, what's C? 12.7 minus 3.5. A equals 12.1. Okay, so this leg here is 12.1 nautical miles. Okay, use Pythagorean Theorem, figure that out. What time am I going to arrive?
You do D divided by
Okay,
S.
yeah, so now I got to do, yeah, what do you do? What do you guys, 60D Street? What do you use? Okay, I don't use 60D Street. I wasn't taught that, but yeah, rate times time equals distance, or speed times time equals distance. This is how I was taught. 60D Street's a beautiful thing because it adds a 60 in there. But, you know, anyway. So, what am I looking for here?
Time.
I'm looking for time. So, time equals distance over speed. Now, if you use the 60, I don't even know what the D is. Is it like this? Is that how it goes? Is that how it goes? Anyway, I don't know. It's 60D Street goes. I might have been wrong. I don't know. I don't use it, so I don't know. Okay. But anyway, so time. I'm looking for the time. It's the distance divided by the speed. What's my distance?
12.1.
12.1. What's my speed? 11. So what's that? That is 1.1 hours. Okay. When I do this, distance divided by the speed, I get to time in hours. Okay.
60, you get the time in minutes.
Okay. So yeah. So now I got 0, 0, 1, 7, and I'm going to add 1.11 hours. So should I go like this? 1, 1, 1?
No,
No, I shouldn't do that. What do I got to do?
you add the hour, then you 0.11 and multiply by 60.
Yeah, okay, so the 1 is going to go here, and this is going to be times 60 there, exactly. So 0.11 times 60 is equal to 7, it's equal to 7 minutes. So this is 107, and that gives me 114. That's when I run.
We'll do 124.
What's that? Oh, Wait a minute. I did the 0124. Yeah, I took it off the wrong. I took it off the wrong. I took part of the answer of number 3, wrote it in number 1. Okay, 0124. I will do one more of those, and then we'll take a break. We'll do number 3. I'll let you look at 3 for a minute. Okay. Oh, it's in my freaking hand. That's ridiculous. 3. This is a beam. Okay, give you another minute. So, by the way, if I recognize this problem, do I have to draw the whole picture? Which one of those is going to be C? The long one or the short one? The long one's going to be C. Which one's going to be the short? So, okay. So if I know that at the end I'm going to go A equals the square root of C squared minus B squared. Okay, most of these Coast Guard problems, this is going to be the long one minus the short one. Okay, but it's certainly going to be the short one is always going to be the Abeam. Okay. So the one that you're going to subtract is always going to be the Abeam distance. Okay. All right. So you might recognize that pattern and you might just bang it right out. Okay. You don't even need to draw the picture. If you understand what they're asking, you might just get right to the point saying, you know what? To calculate my distance, I'm going to take the original length and I'm going to subtract the beam length from that and square them both through square root. Boom. Okay. That's really where we're going here. But I'm going to draw the whole thing out. So you're steering 0, 1, 9. All right, that's something like that. I don't really care about the 19 degrees on this problem. It's 0216. You pick up a light dead ahead at 11.6. Okay? You change course to pass at 3 miles. There's my 3 miles. It doesn't matter if I go to one side or the other for this problem, but let's do it properly. 3 miles on your port beam. That's my starboard side. No, that's not good. Yeah, that's my port side. That's good. I draw a line tangent to that circle. Where's my right angle going to go? My right angle going to go at the buoy? Or is it? So here's another thing. The right angle never goes at the buoy for these problems. The right angle never goes at the buoy. It always goes at your course line. So that means I need a right angle here. What's the distance? 3. Okay. Second term. First term. Long one is the first term. The distance of beam is the second term. Okay. So A is going to equal square root of 11.6 squared minus 3 squared. A is going to equal 11.21. 11.21. So I'm going to go 11.21 miles down this leg. What time is it going to, and I'm doing that at what, 14 knots? What time is it going to be when I'm Abeam? So I do my 60D street or whatever it is, okay? Now I got to calculate my ETA. Based on speed and length of leg A. Okay, so rate times time equals distance. Time equals distance over rate. Okay, I want to get the time, so I'm going to solve it for time. Distance over rate. Distance was 11.21 divided by, what's my rate? 14? 11.21 divided by 14 is 0.8. 0.8. Sierra, this 0.8, what are the units for that? What are the time units for that?
Hours.
That's hours. That's hours. Okay? So if I want to get that to minutes, what do I got to do? I'm going to multiply it by 60. Okay, times 60. Did I divide by 60 in the last one? God, I hope not. Anyway, multiply by 60. Great. So what does that equal?
48.
48. What time did I start? 0216 plus 48. Okay? And you get 0304. All right? So that's the whole problem right there on the board and, there, okay? So there's a little rhythm to those, and you're just gonna have to practice them. Now we go to the beginning of the practice, okay? Now look, page 1.